Now I have to talk a little bit quieter because it's late at night and the kids are in bed. So I've generated this command, which is the second pixel command, which is pixel and the colour and position are held within registers. So you can see that this is actually running away at the moment. I'll zoom in and you can see here it's running quite a bit slower because obviously I'm generating this video as we speak as well, and it's taking up a lot of my CPU time. But I set it up so that it prints out a pixel and then it moves, adds 1 to the value of the colour and 1 to the value of the position, and it just works its way all the way along continually. So it means that you're going to generate a nice kind of pattern. But of course it's going to take a bit of time for it to do it, and I would say it probably runs about 3 or 4 times faster than this whenever I stop recording the video. So you can see here the arrow contains the colour, so the colour can go from all zeros to all Fs, and the position as well will go from all zeros to all Fs. So these are held within here, and if we were to drop down in, you'll be able to see this running away. So you can see it up here, this is the actual code and it's just running in a little loop, and the graphics card is here and you can see all the values being generated. And we'll head down into the actual CPU and you can see this running here, and the control unit, and you see all of the outputs from the microcoded ROM running away. I'll make it a little bit smaller, and if I drop down into the microcoded ROM, you can see the compression ROM here jumping about from different positions, picking out the starting position of each of the commands, and you can see it working through all of the commands and outputting all of the values here to our control unit. Now I generated this using my assembler, so I'll show you the program first of all. So there's our code here. So we're starting off at address 8000. We've got 3 of these directives here. So we've got a starting colour, which is 0, a starting position, which is 0, and the graphics card, which is given by FFF5. And we put the colour into R0 and the position into R1. We then print off the pixel, so it's pixel and it's the graphics card, which is FFF5, and then the R0, R1. We then increment R0 and R1 by a value of 1, and then we jump back to this beginning here, and we just continually do this. So it just changes the value of the position in register R0 and the colour in register R0 and the position in register R1. So a nice little simple bit of code, and I can run through the assembler here. So whenever I assemble it, this is the assembled code here at the bottom, and the command for the pixel is 7101. Now there's no end command in this, I'm just leaving this to run through. So it will probably take a couple of hours for it to run through and fill out every position. Now I will go ahead and generate some other code that will generate some nice visual effects, and of course you're not going to get it running very fast. So I will record it and just fast forward the recording so you can see the kind of effects that you get. Now, it doesn't really matter the fact that it doesn't run super fast, that's not the point. The point is comprehension and understanding how the CPU is working. And I think that this is an excellent learning tool for anyone who wants to get into CPU design, whether it be in terms of the actual architecture or the organization. So that's where I am at the moment. I will be moving on to the second graphics card, which will allow us to import ready generated images, and they will import almost instantly. You know, it will take maybe about 10 seconds for it to generate the whole image. So that's all for this video. I hope you can hear me okay. I'll get you on the next video. Goodbye.